Hello friends, welcome back to the class of thermodynamics. In this class, I will tell you about heat and specific heat. Previously, we have already discussed about heat. Now, new thing has come in the picture which is specific heat. Okay, so in today's session, we will talk about heat as well as specific heat. Now, what is heat? We already know heat is form of energy which occurs due to the difference in the temperature. It is a form of energy due to the virtue of temperature difference. Okay. Now, the transfer of heat takes place in three ways. What are those three ways? Conduction, convection, and radiation. These are the three ways of heat transfer: conduction, convection, and radiation. So, what is conduction? Suppose if we talk about metal, it is made or any substance, solid substance. It is made of many molecules. Okay. Now, if you transfer the energy, what will happen? Energy will transfer from one molecule to another molecule, to the third molecule, to the fourth molecule, like this. Okay. So, this is the heat conduction. When the heat or the energy transfer from one molecule to another inside the solid, this is nothing but conduction. Okay. The molecule transfer energy to the adjacent molecule because of interaction between them or collision between them. Okay. Second thing, convection. What is the heat transfer through convection? When there is energy transfer between solid surface and fluid. When a solid and fluid are in contact, then there is a heat transfer or energy transfer through the convection. How? For example, suppose in a ground water is spread, okay, or in a table, top of the table water is there, okay. So tabletop or your ground, it is solid, water is liquid, fluid, okay. So whenever there is heat transfer or energy transfer between that ground or water or table and water, that is through the convection, okay. So whenever there is energy transfer between solid surface and adjacent fluid which is in motion, then it is heat transfer through convection, okay. There will be conduction also, but very small amount. Major part will be convection, okay, because of the fluid motion which is in contact with the solid surface. Third one is radiation. Radiation, it doesn't require any medium. If medium is there, no problem. But if medium is not there, then also it can take place. How? Due to the emission of electromagnetic waves. Due to the emission of electromagnetic waves. The energy transfers due to the emission of electromagnetic waves. This is radiation. Okay? It can occur without medium as well as with medium. Okay, these are the three ways of heat transfer: conduction, convection, radiation. Conduction in solids, when there is energy transfer between molecules; convection between solid and fluid; and radiation anywhere, okay, due to the emission of electromagnetic waves. Let us see more about heat. Now, previously in one of the session I told you about heat and work. Both are form of energy, okay? And both are path function. We already discussed. Both are path function means they depend on a process or path traveled. They don't depend on the state or property, okay? They depend on the path traveled or process, okay. And both are boundary phenomena. Both are boundary phenomena. How? If you remember example of closed system, this is a closed system, okay. Now here what was happening? there was energy transfer as well as mass transfer, if you remember closed system. Okay, energy transfer was, how was the energy transfer, if you remember, how was the energy transfer? I will tell you how was the energy transfer. One second. So in closed system, if you will remember, there was transfer of energy. It can be in the form of work or heat. Okay, I told you example, fill the bucket full of water, close from the top. I have given you this example. Okay, now there will be energy transfer, I told you. Okay, now mass can't transfer because it is closed. Energy was transferring somewhat from here. Okay, here from bottom you were giving heat and there was energy transfer, I told you. Okay, so it was crossing the boundary. It was crossing the boundary of the bucket. It was from inside the hot water, the heat was releasing outside. It was transferring outside. So it is crossing the boundary. So it is boundary phenomena. Both heat and work, both are the boundary phenomena. Okay. And they are path function. That doesn't depend on the state. So these are the important point about heat as well as work. Now, what is path function? I already told you. Its magnitude depend on the path followed during the process. Okay. But what about point function? It depends only on the state. The magnitude depends only on the state. Suppose pressure, volume. It all depends on the state. P1, V1, P2, V2. Okay. But when we find work done was depending on the full process from one state to another state, how it is traveling. So these are the important points to be noted, which can be asked in the exam as well as when you search for job. The placement also they can ask such kind of questions. So it is important both point for the exam purpose as well as for the placement purpose to get the job. Now specific heat. You have understand about heat. Now next specific heat. Now what is specific heat? It is the energy required to raise the temperature of unit mass of substance by 1 degree. Now what do you mean by this? Suppose this is a system, mass is 1 kg, change in temperature is 1 degree Celsius. Okay, and energy is how much? 5 kilojoule. Means energy required, means 5 kilojoule of energy is required to raise the temperature of unit mass. Unit mass means, what do you understand by unit mass? Write in the comment box, what do you understand by unit mass? When mass is 1 kg, it is unit mass. So energy required to raise the temperature of unit mass by 1 degree. Means how much you are raising the temperature? By 1 degree. So change in temperature is 1 degree. Here it is mentioned here. Delta T is how much? 1 degree. This is the change in temperature. So energy required to raise the temperature of one mass or unit mass by 1 degree Celsius is known as specific heat. So if 5 kilojoule of energy is required to raise the temperature of 1 kg mass by 1 degree, then the specific heat will be 5 kilojoule per kg degree Celsius. This is the unit. Kilojoule per kg degree Celsius. This is the unit of heat. Okay? Understand? Now, specific heat is of two types. at constant pressure and at constant volume. One at constant pressure, another at constant volume. Cp. C represents specific heat. When we say at constant pressure, we write subscript P. If constant volume, we denote by subscript V. So Cp represents specific heat at constant pressure. Cv represents specific heat at constant volume. Now what is this? So first we will see specific heat at constant pressure, Cp, small p. The energy required to raise the temperature of unit mass of a substance by 1 degree. Same as the definition of specific heat. When as the pressure is maintained constant, this term is added extra. When the pressure is maintained constant, the energy required to raise the temperature of unit mass of substance by 1 degree. This is the definition of specific heat. But when the pressure is constant, then it is specific heat at constant pressure. And when volume is constant, it is specific heat at constant volume. So these are the two types of specific heat. Okay. Now for ideal gases, du. Du is the internal energy. This is another property. This is another important property. Du. Du represents internal energy. Du represents change in internal energy. This is nothing but Cv dt. Cv dt. Okay. Now resolve it, simplify it. You will get Cv. Cv equals to du by dt. And this is at constant volume. So small v is written here to represent that process is occurring at constant volume. Okay. Cv represents specific heat at constant volume. So to resolve this, we'll get du by dt at constant volume. Okay. Similarly, this H represents enthalpy. H represents enthalpy. This is another one of the important property. Du represents change in internal energy. Dh represents change in enthalpy. And this is nothing but equals to Cp dt. Okay. So when you resolve, you will get Cp equals to how much? Dh by dt at constant pressure. This is very important. You note down this thing. Very much important. Now, how you know this definition? H equals to U plus PV. What is PV? Ideal gas equation. PV equals to RT. Okay, so DH equals to U plus RT. Then differentiate it. You will get DH equals to DU plus R dt. R is constant. What is R? Universal gas constant or characteristic gas constant. Okay. Now put the value of dh and du. Okay. Now take the dt common. Take the dt common and cancel it. We'll get Cp equals to Cv plus R. We'll get a relationship Cp equals to Cv plus R. Unit is kilojoule per kg Kelvin. Okay. Or degree Celsius or Kelvin depends on the question. So this is one of the important relationship. So one relationship is du equals to Cv dt, dh equals to Cp dt, Cv equals to how much? Du by dt, constant volume, Cp equals to dh by dt, constant pressure. Next, you know H equals to U plus PV and therapy equals to addition of internal energy and pressure volume work. Okay. Now from here, after resolving, simplifying, you will get Cp equals to Cv plus R. Important relationship. Now ratio of Cp and Cv. Ratio of specific heat. It is denoted by either K or gamma. Either K or gamma. From book to book, it depends. Somewhere it is represented by K, somewhere it is represented by gamma. What is this? Ratio of specific heat. Which will be bigger, Cp or Cv? Cp. Why? Cp is nothing but Cv plus R. Plus R is there, na? So Cp will be always greater. And this ratio should be more than 1. this ratio should be more than 1 or equal to 1. Okay, so it is nothing but Cp by Cv. So note down this relationship, very important. Okay, I hope you understand all these things. Thank you for today's session of specific heat. I think you got some idea about the specific heat and different modes of heat transfer. Okay, so it is over for today's session. Thank you and good luck.